So in this video, we're gonna look at the third sub-step under step number 4, called under the obtain the regression model. So after we testing the quality of the sample model, we're gonna move on to see if this sample model can be used to predicting the population. So that's why we're testing the quality of the population model. So exactly the same method we learned from chapter 14. We have two potential methods. One is called significance hypothesis testing. Another method is called the confidence interval of partial coefficients. So the reason we call it partial coefficient is because now we're dealing with the multiple regression model. We no longer call beta 1 as slope. Instead, we call betas as partial coefficient. So partial coefficient. So that's why we call it confidence interval of partial coefficient. So let's look at our methods. So for the hypothesis testing, we have exactly the same two tests, F and the t-test, after t-test. However, here I want to emphasize that in the simple linear regression model, the F and t-test, they are the same test. That's why when I show in chapter 14, and you see the result are the same, even the number, the p-value are exactly the same. However, when you're dealing with a multiple regression model, F and the t-test, they are totally different. F and the t-test, they are totally different. So therefore, don't get confused. So here, when we do a multiple regression model, we have to do F and the t-test separately. So what we have to do first is we have to perform the F-test before we perform the t-test. So So what is the difference between F and the t-test in the multiple linear regression model? So first, let's look at F-test. So the F-test is used to determine whether a significant relationship exists between the dependent variable and the set of all in the independent variable. So the F-test is referred to as the test for overall significance. So usually also people call F-test as the global F-test. So the goal for the F-test is try to look at to see if I consider all the x variable together, think all the x variable as a group. So we try to see if the y variable have a significant relationship with this group. So we are not trying to identify which x variable works. We only try to see, okay, let's see for this group if y variable is significantly related to this group. So why we need to do this practice to do the F-test first? Because think about if F-test after F-test, you show that y variable has no relationship with this group. So you no longer go further to look at which x variable actually works, right? It saves your time. So that's why we always do the F-test first. So as I mentioned about the next step, t-test. So the t-test is the test. Separate the t-test is conducted for each of the independent variable in the model. So if your F-test indicates y variable do have a relationship with this group of the x variable, so your next step will be to figure out, so for this group x, so which one is really playing a role to connect with y? Because sometimes in a group, some of the variable might not work. Just think about your group project. Although your group project may get an A, so some group might say, no, I think some of our group member actually didn't work. I don't think they deserved A. So basically, this t-test would be like my peer evaluation. I try to figure out which student didn't really work. So that's why we do the F-test first. If F-test indicating Y is related to this group of X, and then we're going to go further to perform the t-test. So as I said, we are figure out which X is working. So that's why you have many t-tests. So let's say the model have 3 predictors, 3 x variable, then you will have 3 t-tests because you want to see which one is really working with, can be useful to predict the y variable. So F-test always only have 1 because you group all the x variable as a group, and so to see if y related to the this group of x variable. So now you understand the relationship between f and t. Now you think about why in the simple linear regression model, f and t tests are the same tests. Yes, the answer is pretty straightforward. So when F-test tests as a group, for the simple linear regression model, we only have 1 x variable, right? When you do the t-test for the simple linear regression model, we also only test that 1 x variable. So that's why in the simple linear regression model, F and the t-test are the same test. However, now we'll deal with a multiple regression model. For each model, we'll have more than 1 predictor, minimum 2. So 2 variable, a group, And so, when you consider two, you're testing two variables at the same time. So you definitely have to have a t-test to test individual, right? So now let's look at how we set up the 4 steps, because all your homework and exam are required the 4 steps. So you have to know how to set up 4 steps. As I said, we always do the F-test first. Let's look at the F-test. So step number 1, hypothesis. So the setting of the hypotheses are different from the simple linear regression model. Did you notice that? So like I just explained it, and so you are testing all the x variable at the same time. So that's why you are testing all the betas. Remember, beta is helping us to understand how x variable is related to y. So instead of testing x is a real observation, we are testing the relationship. Therefore, we are testing betas. And the second, we are testing the betas. We're not testing b's. B is used to represent in the sample model. We already estimated. They are not 0. So the only thing we're testing is testing this population. That's why we're using the betas. And third, if you look at it, we're testing all beta equal to each other at the same time equal to 0. So if you think about a similar idea as I explained in chapter 14, if the beta equal to 0, that means no matter how x change, it won't affect y. Basically saying x and y have no relationship, because no matter how x change, y won't change. So that's why we're testing all the beta equal to each other and equal to 0. Make sure, don't forget how to write down your null hypothesis, because that counts towards your grades, right? So you make sure you know how to write down your hypothesis. So the P, here I just showing you the general expression. Later when I show you the example, you will know that depends on how many beta you have. So the P should be replaced by the certain subscript. And the H alternative, make sure you always use this phrase called the one or more of the parameter is not equal to 0. Please don't use any other notations. I had a student who are very creative. They said, oh, the H alternative will be if HO not stands, then HA has to stand, which means H alternative will be the complement event to HO. So they say, oh, let's just write down beta 1 equal to beta 2 not equal to 0. So the answer is wrong. So beta 1 equal to beta 2 not equal to 0 is just one scenario. You also can have beta 1 not equal to beta 2 and not equal to 0, right? Or beta 1 equal to 0, beta 2 not equal to 0. So you have so many different scenarios. You have to include all of them to construct your H alternative. So actually you will end up wrong, because you won't be able to, sometimes if you have more than 2 betas, and you actually need so many different scenarios. So the simplest way actually is just write down this sentence called one or more of the parameter is not equal to 0. So this is the best way to write down your H alternative. So similar first step. And the second step, finding the p-value from Excel. Third step, the same rejection rule we learned from the simple linear regression model. You're going to reject HO if the p-value is smaller and equal to 0.05. And your decision will be if you're going to reject or not reject your HO. And your conclusion will be if the model is significant or not. So let's look at an example. So please find your handout related to the Spark Club. So look at first page. First, we're going to do my F-test. We're going to find the p-value from these outcomes. So exactly the same place you'll find for the simple linear regression model. So it is under the second table called ANOVA. So at the end, we have the F-test. So the significance F is the p-value you're going to use to do the F-test, right? So 0.042, smaller than 0.05, right? Do you reject HO? Yes, you're going to reject HO. So how about the significance of the model? So which means beta 1 equal to beta 2 equal to 0 won't hold. So that is the wrong assumption. So that means the model actually is significant, right? Reject HO means you're going to have a significant model. So let's look at how we formally write down these 4 steps. HO, beta 1 equal to beta 2 equal to 0. Like I said, again, we didn't have the beta p because for this example, we only have 2x, x1, x2, so that's why beta 1, beta 2, right? So the H alternative, there is no shortcut. You literally just use exactly the same phrase you saw on the slides. One or both of the parameter is not equal to 0. So I use both in that of one or more because we know we only have 2 x variables. So the p-value we just find 0.042. So the same rejection rule we always use. Reject HO if p-value is smaller equal to 0.05. And so the decision will be reject, right? Reject HO and conclude the model is significant. So this is my F-test. Very simple, right? So now we look at the t-test. So for the t-test, the setup of the t-test are very, very similar as the simple linear regression model. Actually, almost the same. So except your HO, when you set up your hypothesis, the first step depends on which beta you're testing. You have to replace this subscript I by that specific numbers. So if you're testing beta 1, so here should be beta 1 and beta 1. If you're testing beta 2, here should be beta 2 and beta 2. So now let's look at where to find this p-value for the t-test. So the same place as you find from the simple linear regression model. So keep in mind, we never use the first row under the p-value column. The reason is this first value here is the p-value for B0. We never test the B0. It doesn't matter. We only test the B1. But here we have the two betas, beta 1, beta 2. So that's why we have two p-values. So the first p-value, 0.018. So that is the p-value you're going to use to testing the beta 1. And so that's why it's the p-value used to test the individual significance of the size of the ads. So the p-value under it, 0.38613, that is used to test this row's variable discount amount. So you're testing if the discount amount is going to affect the number of new members. So let's write down formally. First, we're going to test my first beta. So you can see the beta I is replaced by beta 1, right? Because we're testing the partial coefficient for the size of the ad. So then we write down our p-values and the exact the same rejection rule. So the conclusion is we're going to reject HO. The decision is we're going to reject HO and conclude that the size of ads will significantly, I'm missing a word, affect the number of the new members. Significantly affect. So how about the t-test for the beta 2? So the p-value we found from Excel is 0.3861. So therefore, we cannot reject HO. So then the discount amount will not significantly affect, I'm missing keyword, affect the number of the new members. So this is the hypothesis testing to test the quality of the population model.